One second. I'm not as tall as you Dutch people generally, so sorry. Okay, cool. Hi everyone. So my name's John. I'm a solutions architect for a company called Snowplow. I'm Australian, which means I talk pretty fast and I have a really funny accent, so I apologize. And just a quick warning, if I say the word data or data, they just basically mean the same thing, so no need to get upset about that. So I work for a company called Snowplow. For those who don't know, so Snowplow is a customer data infrastructure platform. So we basically work with customers to collect data from their website and app or microservices and stream that directly into, say, Snowflake or Databricks or any of those big data warehouses. And then our customers will then essentially build data models on top of the data that sits within the warehouse. So if I start, just a quick show of hands, does anyone work for a business that kind of collects digital data from like a website, app, or microservices? Okay, that's a bit less than I was thinking. Who finds it easy to work with that type of data? Okay, one person, awesome. And I guess the last question is, who has seen one of these things before? Okay, cool, about 30%, 40%, if I had to guess. All right, cool. So today I'm going to be talking about data modeling for event data specifically. So when we're talking about event data, it's essentially data that captures an action either person, so an individual, or a service, so like a system like generates. And it's basically capturing at that point in time what action was taken. And what's more importantly here is something we call states. So the key difference between event data and some of your more analytical data, I guess, is that event data tends to be more of a flow. So you want to know about the sequence of events, essentially. So you kind of look at what event A is, B, and C, and you kind of want to map the state across those multiple events. While transactional data tends to be more that moment in time, and you just look at that single event without worrying about what came before and not worrying about what came after. Cool. So another subcategory of event data is what we call behavioral data. And so behavioral data is this really rich data that basically allows you to tell what a customer or individual is doing minute by minute and second by second. And because it's such granular, it tends to be, I'm going to use the word AI once, and I promise them again in this presentation, it's basically the fuel for AI, right? Because it allows you to explain what an individual has done and also predict what they may do in the future. And some characteristics of this data, it tends to be quite raw and atomic. And when we say atomic, it means it's like the most minute measurement and you can't break it down any further. And it tends to be unopinionated as best practice, and which basically means you don't apply business logic to the event data until you come to the data models later. So you kind of want to just capture what happened in terms of an action. It tends to be quite large volume as well, and it's also very messy. So it's quite hard to kind of derive insights or build robust data models on top of this data, just because it's very context dependent. So very often we don't really care about just what event happens, but we also want to know the circumstances that surround that event. Cool. So this is kind of like our majority of teams currently do event-based tracking design. So it's basically known as application first events. And the way it works is whoever's responsible for that event collection, they basically are given like a website or app, and then the way that they do this tracking design is essentially, okay, what can I see as part of this visual? I want to track events based off that. And it has some benefits, right? So this application first design is really good because you have visual. So for non-technical stakeholders, they can basically describe to the technical people what they want to track on a website. And it's quite easy to adopt because there's no arguing about what does this dimension or metric mean from an organization semantic level. There are some cautionary tales about using this event-based design. So the first thing is the data quality. If you basically just base your events on the visuals, eventually what you get in bigger companies is you start to have hundreds and hundreds of different distinct event names, and then no one actually understands what that event is describing or what event to use for a particular use case or to answer a particular business question. And this is kind of what you can expect it to look like if it's kind of an event first event, which is bit funny. This is kind of what it would look like in the warehouse. So essentially you can see this is an example add to cart event on the far left there. So you have an event name, and then you essentially have these key value pairs where essentially you have the properties that kind of describe what the event was, but it doesn't have inherent semantic meaning. So if you were looking at like a key within that column for the event property, you don't really know what it relates to or kind of like what it means without having to reference other columns or like other values in that particular row. And so there's also this thing, so like, business stakeholders will come to you if you're like a data analyst or analytics engineer, and they'll have a whole bunch of questions. And then the question for you then is like, okay, to answer a particular question, what corresponding event do I have to go back and look at? Like, you don't have that information, which is kind of what we describe as the blank page problem. So the blank page problem is basically where you're given like the scope of a problem, but then you're essentially starting from a blank state and you don't exactly know where to go for the answer. So you're kind of like working from zero, and like how do you actually take a step-by-step approach to kind of move towards that final solution. And also use cases. So like with behavioral data, like there's quite a few powerful use cases you can do. So you can do like things like, customer 360, you can look at customer journeys, but then most businesses want to do like digital transformation. So then they're like, okay, now I have this next use case, but then don't have the data to kind of the good quality data from the source to kind of support it. So without kind of knowing what that future use case may be, like how can you define the events that you want to track or collect from your digital estate? So there's obviously an alternative, which is the whole point of this talk. So the alternative of this is what we like to call entity first driven design, or what I like to call like a business first foundation. And the way it works in theory, because we start from theory, is essentially you have that middle layer as kind of your collection layer, which collects the event. And that is essentially an abstraction of all that business context that is important to you as a business. And anything or use case or application of that data kind of sits on top of that unified behavioral data foundation and that business context, so that regardless of what use case or like end goal that you want to use data for, that changes, but the static state always stays the same below it. Because if you kind of think of a business, businesses are like creatures or systems that are quite slow to change. And if you kind of go to a business stakeholder and you ask them like, how does your business operate? Like it's very unlikely that it will change within like 6 months unless you get a restructure or like some other thing like that. And at the core of this business first foundation, or what we call entity driven, these things we call entities. So entities are basically what you can use to describe the different phases of time or manner that an event happens in. So you can kind of think of them as like the objects that you attach with an event. So this is kind of like an example of an event. So here we have a page view event. So very often people don't just care about that an individual viewed a page, right? They want to actually know like, who that individual was that viewed the page, as well as what page that you kind of viewed. So the two entities here would be that shopper entity, and then that web page might be like a page entity because it gives the context for that actual event action, which is where that rich granularity and the actual quality of that behavioral data comes from. It's the context and not the mere fact that someone did a particular event. So this is kind of like another example. So as you can see here, this uses like a modularity design in the sense that entities can apply to multiple different types of events. So here, this is an add to cart event. So it changes from a page view to add to cart. The shopper and the page entity stays the same because you're still adding products on a page. It's still a shopper adding a product. But now we can introduce something like a product entity. So what was the actual product information that you added to the cart, as well as what the cart value was at that particular point in time. So we now have essentially an add to cart event, but then we have all this rich context that surrounds the event, which you can then start building additional data models on top of. And this is my favorite picture. So I live in the UK at the moment. So we have this fellow called King Charles. And King Charles is a very nice fellow who's like male, born in 1948. He's wealthy, married twice, and lives in a castle. So the reason like context outside the customer matters is if you're just looking at the customer itself, like it doesn't give you the context, right? So you need to have this additional rich context to kind of describe all the surrounding circumstances of an event, as opposed to looking at just the customer. Like the customer is important, but you need all this other information to kind of inform and basically explain why they did a particular decision, but then also predict what they may do in the future. And this is kind of what you can expect like an entity first event to kind of look like in the warehouse. So this is a Snowflake table. You can kind of see it's the same add to cart events, but now you have like separate columns for each entity. So here you can kind of see there's a page entity, there's a product entity, and there's also like a cart entity. So you can kind of like reference the column name And then so say, for example, if you grab like the items key from that cart column, you can immediately know it's the items that belong to the cart. You don't have to go and reference other columns or look at other external documentation. Like it's self-explanatory what these attributes mean, and it kind of brings that semantic meaning to the forefront as opposed to a ad hoc thing that you have to do once you start querying that data. So if I was a beta man, which I'm not, I'm guessing that anyone that writes data models, they kind of like follow this little structure here. So you essentially have your source layer, your staging, intermediary, and your marks. So the question, I guess, now is like, how can we define our entities? And the answer really is we kind of have to build abstraction. So the way that abstraction kind of works is it removes the details and it kind of boils down from and translates the data modeling from more of a technical problem into a business problem. And that's where the true value of data modeling comes from. It's like if you can help a business drive value. It's not if you have the most fancy technical DT models, which is cool and fun, but you kind of want to relate back to the business. So this is like the traditional way of data modeling. I'm not sure how many of you guys still do this, but because DBT is such a great tool and it's so easy to get started with data modeling in general, like it's very easy to put yourself in a rabbit hole essentially and build like a swamp of mess, right? So it kind of takes this computational from a mental perspective to make sure that you know exactly what your data modeling is kind of like the key to success. So the way it kind of works is you obviously have your physical data model in the warehouse. So this describes all the attributes, the types of the columns, and kind of like what tables you have. You have your logical model, which is kind of like that first abstraction layer where it's removing like the actual data warehouse. It doesn't matter if it's like Snowflake or Databricks or Redshift or BigQuery, like that logical data model applies to all those warehouses. And then you take it to the furthest level, to the conceptual level, which is essentially you're describing all the entities that matter for you as a business, how they relate to each other, and maybe if you want, then maybe add a little bit of detail to it if you need. But the idea is you want to build like an entity diagram first, that is kind of like a reference architecture, and then work now on filling data into that model itself. So one way that you can kind of do this is what we like to call domain models, which is essentially where you're mapping. So what you do is you get a whole bunch of like business stakeholders in a room, you tell them to explain to you in human language how that business operates, and then you just draft like the diagram on a whiteboard or piece of paper or just kind of draw, which is pretty cool. And then, so for example here, this is like a business stakeholder that's telling you how a business e-commerce operates. So you have a customer, they add products to your cart, they may say ads on the thing, and then you basically, as they talk, you basically plot these entities on a page and you basically draw the relational diagrams against each entity. And the idea here is the business. What you're trying to do here as an end goal is you want to describe the business as if it was static, and if you're working in an ideal world that's kind of unbiased, and like so if things go the way that you want, this is how a business would operate in an ideal world. And then essentially whatever data or use case that you need to use these entities for, that's subject to the business interpretation. So that's kind of like the business logic essentially is like you apply it later as opposed to from the source of that event data. And if you work for really big enterprises, it's really hard to find out who owns a particular domain, right? So what you can also do here is you can have like multiple subdomains and you can kind of group them together to become like this overall picture. And one key thing also is for these domain models, it's very important to also identify an owner in the business that kind of owns like the boundaries, kind of like, so the owner is basically responsible for defining what the domain looks like, as well as like kind of what it is included in it. And that's because I strongly believe if you have like multiple people owning a problem, it just basically means no one owns it, right? Because you're shifting the ball across each other. Okay, cool. So the first step is obviously like, defining the entities, but then like how do you define what events do you need to track as part of that entity? So let's use a video game example because I want to do something fun. Everyone knows what this is, right? Cool. So if you were kind of doing like event tracking for this, right? Like how would you start? So the first step is you want to identify the entities from that conceptual level. So here we have a character. It could be Mario or Luigi. Mario is calling him Luigi, but that's up for debate. They may play like on a particular level. They may land and jump on platforms. They may like collect items like coins. They may then also use power-ups to become like bigger or rainbow. They can also enter tunnels to kind of go to the next level, and then they can also defeat enemies. So here we basically mapped like the key entities as part of this Mario game, and then just like from a very high level, giving like a human description of what each entity means. So here, for example, the character, you might put a description, just be like, this is the player, this is the entity that is controlled by a user, as an example, right? So it's the human description of what that entity means from a point of view of the business as a reference point, as opposed to a technical perspective, essentially. The next thing is you can kind of give them some attributes. So this is kind of like one step up from the abstraction layer, because you kind of define those entities, and now we're looking at like, okay, what are these attributes that we care about for each entity? So there are things like, for example, you know, the character type, so it's a Mario or Luigi. For the level, what the level ID was, what theme is it, like is it underground, is it in a castle? The platform type, is it a break, is it, you know, breakable? And then so you kind of map in all the attributes to the entities themselves. So one caveat to this though, when you are defining the entities, you kind of want the entity itself to have its own identity. And what that just basically means is, say you have a character entity, you don't want it to be defined by like an attribute within that entity. You kind of want the character to be a character entity, and that gives its value and identity. So essentially what you don't want to be like, the character is dependent on the character type. You kind of want it to be standalone because you're not worried about the data. As step one, you only really care about the overall object itself. Okay, cool. So the next thing here now, so you have your entities. So in green are entities, in blue are entities, but there's two types, right? So there's like global entities. So global entities are essentially entities that apply to every single event. So they could be like, if you're using the Mario example, so like Mario is the main character, so he's the main entity that gets applied to every single event, okay, regardless of what that event is. And then because you're always on a level, so that is also like an entity that applies to every single event. But then you have event-specific ones. So these are like entities that only apply to a subset of events. They may not be necessary for every single one. So here you can kind of see like, so based on this, say you have like a character, so Mario, they defeated a mushroom as an example. So here you then have like the enemy as the entity on the far left, and then defeated is kind of the interaction that changes the state or of that entity that you're interacting with. So you kind of can do this horizontal and vertical mapping or matrix. And then based off that, you can then translate it to your actual events. So here you have kind of like the event names. So here you have like defeated enemy, break platform, enters tunnel, and so forth. Yeah, so bringing it all together, this is kind of what you'll look like. So the idea is you have your main events in the middle there. So these are the events that will appear in your data warehouse. You then have event-specific entities, like for example, enemies only relevant to the defeated enemy event. Why, for example, the platform could be related to 3 distinct events. Why the character and level basically applies to every single event, regardless of what it is. And one key thing to note also, you can have like multiple entity types attached to the same event. So it's not saying it's a one-to-one relationship. It can be like a one-to-many. So as you can kind of see here, like, for example, Mario, the character entity, they defeated an enemy, and the enemy was the mushroom, and it happens on this level. So you can kind of like map multiple entities to that single event. So bringing it all together, this is kind of then what you expect to see like in a Snowflake warehouse. So here now you have the distinct event names on the far left. You still have event-specific properties. So they are essentially properties that only apply to a particular event and aren't reusable, so not modular in that particular sense. But then essentially what you have is you have a separate column for each entity type, which is kind of like, can be like an array of records as an example, or it could be a single record. So that way you can kind of then, if you need to query, for example, like who was the enemy that Mario defeated, you can do like select context character So you can do select context enemy dot enemy type, and that's the mushroom type. So it's quite easy to kind of get to that insight without having to do this wrangling and unnesting to kind of get to that data itself. And so kind of bring it all together, last slide, I think, or second last slide. So finishing off with DT, because it's DT meetup. So this is kind of how it would work. So you can kind of imagine all those entities that we defined, that essentially will become your domain model or domain layer. So that's the thing that kind of sits in between your business and any use case of the data. And the idea is the domain model is an abstraction layer, which basically hides how the business, sorry, on this one here. So the domain layer is kind of like this abstraction layer that kind of hides the source and staging layer. And so any people that want to consume the data, essentially what they'll have to interact with is a presentation layer to kind of like so the presentation layer is kind of like the domain layer, which contains all the single source of truth, and then it's kind of that presentation layer is then the usable data, so it's kind of like the marks in the DT terminology. And the idea is like you always interact with the presentation layer anyway, and you wouldn't like necessarily have to interact with the domain layer or staging layer. And the benefit to this approach is, say, for example, if you're using Snowplow for the event data pipeline, but then you decide to switch to another tool, no idea why you would do that, but say you switch the tool, it doesn't really matter because that domain layer is based on a business definition. It's not tool agnostic. So regardless of what tool is like pumping the data in, that domain layer can kind of stay the same, while like all you really have to care about is interacting with that presentation layer. You don't have to worry about like, what is the behind the scenes thing that is powering this thing.